made a video that perhaps will help you study for your exam and talk about a few of the questions and topics that you may have found a little more difficult so far. This is the lab quiz, and in it I first provide you with 11 years of data, um, uh, uh, all the way from 1992 to 2002, and you can count that there's 11 years of record, and then the largest flood or the largest flow rate for each of those years is listed, and the inquiry is about what is the recurrence interval for a value of 63. Well, it's possible first we want to apply this equation, recurrence interval equals n plus 1 over m, which showed up both in lab and in lecture as a useful computation. And in this case, n is the number of years of record, and m is the rank of the storm we're trying to analyze. In this case, if we look down the list, we discover that 63 is the fourth largest of all the events, and therefore m, which really that n should be an m is equal to 4, as I've shown here, and n is the number of years of record, of which there's 11, and for whatever reason we have to add 1, so 11 plus 1 divided by 4, which is m, the rank of that particular storm. That's 12 divided by 4, gives an answer of 3 years. Another problem that is useful to review on this quiz is the method, the very best and simplest method for creating a maximum strength hurricane using the hurricane simulator. It obviously needs the warm sea surface temperatures, so in order to try and make a Category 5 hurricane, finding the warmest sea surface temperatures is the first step. Moving the storm slowly in order to give it a great deal of time to absorb energy from those warm sea surface temperatures is important to make a powerful hurricane. And if the hurricane manages to avoid landfall, that is the final ingredient in forming a very large storm. So when you act as the hurricane maker, these are the rules. As we saw in the city of Armero, even a city that's over 50 miles away from a volcano is still susceptible to a lahar, a mud flow down a steep mountain valley, and that's exactly what happened. So false, 25 miles is not even a safe distance. For the next question, two factors that are important in landslide potential, and I did note that I was looking for answers in which I specified your analysis of landslides in Hazard City, and in that particular exercise the factors were simplified and reduced to some extent down to two, and they were soil stability and the type of material, and the other factor was how steep the slope is. And those two put together created a 2 by 2 matrix, which each box had a different suitability for landslide potential. Many of you wrote down the suitability as one of the factors of landslide analysis. That's actually the answer. The two factors that are considered to get to that answer are these two. Additionally, when we discuss when you analyze the problem of people needing emergency shelters after an earthquake, the important information that went into your analysis was the type of structures that were in the community and how many people live in each type of structure. And finally, you may also consider the Mercalli index, which helps to tell how many of these structures are destroyed, and therefore how many of those people who lived in those structures are going to be homeless and end up needing emergency shelter. This two-pointer right here was a very useful question and idea, because even though talking about a tsunami and its occurrence and storm surge and risks and dangers, primarily the actual elevation above sea level that an area is the determining factor of how much damage can be expected from a tsunami. And it's a very clear relationship. For a 20-foot storm surge, a building that's at 21 feet above sea level is going to be unharmed, and a building that's at 19 feet above sea level will receive damage or flooding, and a building that's only 10 feet above sea level will probably be destroyed. The Flood Insurance Rates Lab, there were 3 factors that we used to look at the tables and find a flood insurance rate. One of them is which flood zone the house is in, outside of a flood zone, in the 100-year flood zone, etc. We also considered, and they do consider this for the process of setting flood insurance rates, whether there's any history of flooding in the area. And finally, basement. Whether there is one or not is really important. A house that may not otherwise have a problem with flooding, if it has a basement, it has that anything that's in that basement is at risk, being so much lower in elevation than the building itself. Finally, in this question, which was the GIS question, the 2 tools that I asked you to circle are how do you measure the width of the valley, for instance, which is here, drawn here, and to measure the width of the valley we use the measure tool, which is this one right here, which looks like a ruler. And the other thing to circle is turning off the notable features layer, which is controlled by this checkbox right here. The base layer is controlled by this checkbox right here. I'd also like to point out that the most recent quiz that we had in lecture, the one that we all did together, which haven't had a chance any place to hand it back, there's a copy of that quiz with the answers included as well in this handout. The last thing I'd like to do in this discussion is to talk about how you might go ahead and answer the picture questions. And here's an example of one of the picture questions that you might see on the final exam. And always the picture questions, to get full credit, you have to not only identify what it is, but say something important about that. And it's up to you to judge what's important, and there's many possibilities for what could be a good answer. This is actually a system which detects tsunami and transmits them to through a satellite to monitoring stations. So it's a tsunami monitoring system, a tsunami warning system. What's interesting about this is that the sensors themselves are placed at the bottom of the ocean. Whoop, the sensors over here, those are just anchors. The sensors are placed at the bottom of the ocean, and in that way, only a tsunami wave will create a difference in pressure or a disturbance in the water to set off this warning system, which will then shoot the signal up to the buoy and then translate it and send it up to a satellite to be broadcast around the world. You recall that a tsunami wave, or any wave that is, only affects the water to a depth that's equal to half the wavelength. This sensor is 6,000 meters below the surface, which means that only a wave with a wavelength of greater than 12,000 meters will actually create a signal in this pressure sensor at the bottom of the ocean, and therefore surface waves will cause no effect on this transducer and won't provide a false alarm. So that was kind of a wordy and long answer, but it does illustrate that full credit on these picture things, these picture questions. It requires you not only to identify what it is, but to say something important, scientific, or otherwise interesting fact about what it is that you have identified.